Grade 4s. Today we talk about input and output energy. Video 4, 10 July. I think this should be July. I thought I made a mistake there. Did you write June or did you write July? Thinking for yourself, because this was also a democard thing of the teacher, because this was last weekend. So video 4, 10 July, input and output energy. So this is the summary. I want you to take out your NS copies and turn to page 62 there. Okay, there's still quite a lot of background noise with the rain on the roof, but I'm trying. If it disturbs you too much, if it is too disturbing, I'll make the video over. So I'll try. Yesterday in school, we said sound is a form of energy we can hear. Clap your hands, drop a book, sing or play the radio. These are all forms of sound energy. You will learn more about sound energy later in this module. The intensity of a sound is measured in decibels. They do have a machine. That measure that. So blowing a vuvuzela makes a lot, 127 decibels of sound, which is a lot of sound energy. Thunder, 120 decibels, but that's when it's far away from us, I think. The sound of a person breathing measures 10 decibels. You don't have to know these, just the word decibels. Okay. Many objects make sound energy. When sound is not welcome and becomes annoying, it is called noise pollution. That is one thing I want you to remember. And decibels. Any kind of energy, remember this, any kind of energy it needs something to put it into movement, and the energy starts here and it affects something else, and then that also, and that also. It is transferred from one to the other. So look, if you look at this, the movement energy created by your hand was transferred to the book. So you pushed the book, which created movement energy as it fell off the desk. And when it fell on the floor, you heard sound energy. Yeah. So there are different types of energy. Okay, now we're going to turn over quickly. Sources of energy. These are also things you don't have to remember for the tests or the exams. But if you see this, an example of a source of energy is food. Living things need food for energy. The food that we eat has energy stored in it. When we eat it, this energy is released in our bodies for us to use to run, walk, learn, breathe, smile, and do other everyday things. Some other sources of energy that you may know about are wood and coal. Think about a wood fire, heat and light energy. The fire gets its energy from the stored energy that is in the wood. So if you have a fire, wood is the source, and fire also, like a match or lighter. And then also coal. South Africa is lucky to have huge amounts of coal under the surface of the ground. This is used to generate our electricity. Most of our coal is found in the Highveld in the Limpopo and Mpumalanga areas. Almost all of the electrical energy used in South Africa comes from coal. Okay, so, and also oil. Oil is mainly drilled out from under the sea. Crude oil is a thick, sticky, and toxic liquid. Crude oil is used to make many products. Some examples are petrol and diesel, paraffin, which is used for heat and light energy, in paraffin lamps, jet fuel, which is used for aeroplanes, and candle wax. South Africa is not rich in crude oil deposits, so we have to import oil and petrol from other countries. Then there's also natural gas. Natural gas is also drilled out of the ground and usually found near oil deposits. Most of the natural gas that humans use is for heating and cooking with gas stoves and other cookers. Okay, so that is just for a little bit of information about energy. Now, electrical energy is of very little use to us. Before we do that, input and output energy. Just circle that for me quite nicely. Okay. Electrical energy is very little use to us, of very little use to us, unless we have ways to convert it. It must be converted into something. That's why I said energy flows from one thing to another. Machines and household appliances convert electrical energy to other types of useful energy. Appliances such as electric stove or oven, a hairdryer, an electrical heater, a radio, light bulb, convert electrical energy into other types of useful energy. Electrical energy is transformed into heat, light, sound, and movement energy. Electrical energy is transformed into heat, light, sound, or movement energy. Let's see there. Electrical energy is transformed into heat, light, sound, movement energy. Electrical energy is called input energy. So we need the electricity to give input to all the other things. So for an electrical stove, electricity is the input. For a light bulb, electricity is the input. An alarm clock that works with electricity is the input. So now this page we are going to fill in. You have this there now. List the machine or appliance. So we're going to write the name, write the input energy, that is the thing that makes the machine work, right? The output energy, the energy that is produced. So we're going to do that now. You see, there is the example, a stove. There's the name of the stove. Its input that it takes to be used is electrical energy. And its output, what we get from it. So something goes in there to make it work so that we can get something from it. So a stove, the input of a stove is electrical energy, and the output is heat energy. So we use the heat to cook our food. And sometimes there's even light energy that we can get from there. Now the battery of the torch, this is a torch. Its input energy is actually a battery. You know, you put batteries into a torch for it to give us what? Light. Okay. A radio, if it's this kind of radio, normally it has an electrical plug. Sometimes you can use these radios with batteries also, but batteries, when you use batteries, it's very soon the batteries are flat. You can't use it anymore. So I think electrical, no, this is a radio. Sorry, this is a radio. A radio. And its input energy is electricity. And what does it give us? Sound energy. Because you hear it. No? Yeah. And this rattle that a baby uses, what is the input energy? Okay, it's a rattle first. I keep on forgetting about the name. A rattle, it makes a sound. What is used to make this sound? There is no electricity for that. Yeah, it is the baby's hand that uses it to move. So it is movement energy. Movement energy. That makes this what? This sound energy. Think of a baby rattling this thing. Okay. A kettle. A kettle is now very easy. You should know. A kettle. It uses electricity. Sometimes you have gas stoves, electricity, and you boil your water in a pot or a special kettle for gas stoves. But most of the time we use a kettle, and the input energy is electricity, and the output energy that we get from a kettle is heat. Yeah, hot water, boiled water. Then there is the bicycle. Does this bicycle work with electricity? No, no, no. What makes it move? You. If you drive a bicycle, it is you. It is you that put this movement in motion. So you can say you pedal, no? But it is movement because you move your legs like this. So it is movement energy. And the output energy is also movement. So a bicycle, there's no electricity for that, no gas, nothing. You pedal it, so you move. You move to get movement energy. See, you can also write pedal because the pedal is also part of the input energy, but your movement with your legs, your movement is also putting into action the movement of this bicycle. So the output energy, your input is your pedaling, and your input is the pedaling, and your output is the movement of the bicycle. So that is quite easy. Now, a car is also quite easy. There are two things. It has a battery, eh? It does have a battery. But the main input energy of a car is fuel. Petrol or diesel, eh? Fuel. See, you have to put in fuel into your car, or your dad's car, or your mom's car to make it move. Okay, so what is the outcome? If you have a car, you put fuel in it, and you switch it on, then it turns into movement energy. Now, this is very important that you remember this. In your big test, there will be a question about this, and for that you can get, there's 1, 2, 3, and there's 1, 2, 3, 4, 5, 6. So you will get 18 or 21 points in the test if you know this part. So start learning it now. Okay, we're going to fill in a page as well about that soon. But we are going to stop here. So please make sure the main thing that you should know, where is that page? Oh, it's in the, it is in these copies that you have from your book here, the NS book that is copied for you. So you, please remember, just remember here that any energy needs input and output energy. And then what you should remember here is decibels. Sound is measured in decibels. And when a sound becomes annoying. If your neighbors make a noise constantly with very, very, very loud music, they make noise pollution. You've learned about pollution, eh? Wasting things, wasting stuff into the rivers and disturbing the environment. And that is also with sound. It can happen unless it's normal, natural sounds. Hey, so a neighbor and a neighbor's dog can make noise pollution, which is very annoying. There's also the keyword there, decibels, the units which are used to measure sound. So for now, this is where we are going to stop. 10 July 2020. Okay, and on this page also. Now, where is it? It's about this page that this video is today. Video 4, 10 July. Okay. Next, we will work on the ear and the sound of that. So, enjoy this. Go and read this. Do this. Don't neglect your learning subjects. The maths is important, but don't neglect these also. Okay. Enjoy this. See you later. Bye-bye.